Good day, everyone. I am Caryl Margarette Respino, and for today, we're going to discuss the different ways to obtain the liquid limit of soil. According to my reference, the Geotechnical Engineering book by Engineer Galisania, there are three ways to determine the liquid limit. As we go deeper with my report, we're going to tackle thoroughly these three similar methods. But first, let us define liquid limit. It is the minimum water content that the liquid state soil has that still contains any shearing strength that contradicts the soil to flow freely. Okay, there are three ways to determine the liquid limit. According to the Geotechnical Engineering book, there are three ways to determine the liquid limit of soil. First, it is the cone penetration method through the use of a full cone apparatus or cone penetrometer. The second method is the Casagrande cup that uses a mechanical liquid limit device with grooving tool. And the last method, it is the one-point method that somehow is connected with the Casagrande cup method. And now, let us discuss the cone penetration method, wherein this type of method offers more accurate value of the liquid limit of soil aside from the two other methods. The apparatus that will be used in this method has a cone that has an apex of 30 degrees and a mass of 80 grams. This is done through the free fall of the cone for 5 seconds. Since the exact value of the liquid limit of the soil is hard to identify, this type of method requires 3 or more times to be done with different amount of moisture content. The house of this method will be specified in the next slides. This is the visual of the apparatus needed in order to perform this method. This is called as the full cone apparatus or cone penetrometer, which has a stainless steel cone with a 35 mm length that is assigned in penetrating within the soil. To begin with the process, the first step is obtaining a soil sample and letting it air dry for 24 hours in an evaporating dish. After this, the soil sample will be sieved in an ISC with 425 microns, making an output of a fine-grained soil that is needed for the Atterberg's limit. The fine-grained soil includes clay, silt, and fine sand. After the sieving process, obtain about 150 grams of soil and add distilled water and use spatula to thoroughly mix until a uniform paste is achieved. Place the soil paste inside the 50 by 50 mm cup of the cone penetrometer. Before advancing to the next step, make sure that the soil is leveled and there is no trapped air between the soil paste through tapping the cup numerous times. After leveling the soil paste, place it below the cone and adjust the cone until it reaches the surface of the soil. The indicated value above will be the identified initial reading. Next is pressing the button at the side corner of the device so that the cone will free fall for 5 seconds, and the new indicated value will be the final reading. In order to obtain the penetration value, it is the difference of the final reading from the initial reading. After determining the penetration value, the next step would be identifying the water content of the soil through oven drying method. The soil paste will be placed inside the thermostatically controlled oven, and the device will automatically compute the water content. After obtaining both the first test's penetration and water contents value, the test will be made 3 or more times while increasing the amount of distilled water little by little. In this method, the liquid limit is defined as the water content at which the cone penetrates the soil at 20 mm in 5 seconds. As shown in this table, the value of the water content and penetration was recorded for future reference. Usually, after several tries for the test, the data will be plotted and will approximately form a straight line. In order to obtain the liquid limit, you shall find the intersection point of the 20 mm penetration and the moisture content from the line. Next, Moving on from the first method, the second one is the Casagrande cup method, wherein this method is a bit more handful than the previous method. To obtain the liquid limit with this method, the point of intersection between the 25 number of flows and the moisture content between the line must be identified. This is also done in 3 or more times for the better accuracy of the liquid limits value. A brass cup with a hard rubber base is used in this method, and the apparatus is called mechanical liquid limit test device with a grooving tool. The brass cap elevates 1 cm from the base through crank revolution. Usually, the first 3 steps of this method are similar from the fall cone method. Obtain a soil, air dry for 24 hours, sieve, and add distilled water to once again achieve a uniform paste. The next step would be adding the soil paste in the brass cup and spreading it with the help of a spatula. Make sure that the soil paste is leveled with the lower lip of the cup. After leveling, groove the soil parallel to the rotation of the crank. Usually there are 2 types of grooving tool. The first one is the Casagrande grooving tool to be used in the clay type soil. The other one is the ASTM tool to be used in a sandy-like soil. For this matter, the grooving tool to be used is the Casagrande grooving tool. After the grooving process, start turning the crank with a speed of 2 revolutions per second until seeing a contact of 12 mm long of soil in the middle. Make sure that the contact was made through flowing and not from slippage. If the contact had happened through slippage, please disregard the soil paste and repeat the whole process. Record the values of the number of flows and the water content each test. By the way, in order to know the number of flows, there are indicators at the left corner of the apparatus that shows the value, and it must be between 15 to 35 flows. Also, do not forget to obtain a 10 grams of soil from the center of the groove in order to define the water content through oven drying method once again. After identifying the water content, record the given values at the table for further reference for the graph. Repeat the whole process for 3 or more times. The connection between the number of flows and the water content of the soil is that it is indirectly proportional to one another. As the number of flows increases, the value of the water content decreases and vice versa. The graph shows the relationship between the 25 number of flows and the water content. The liquid limit is identified through intersection point of the 2 values within the line. For the last method, this method requires less work since this is only done in one go. It is connected with the Casagrande cup method wherein once the number of flows reaches between 20 to 30, you can stop repeating the long process and use this method instead. The one-point method is established by the U.S. Corporation of Engineers in 1949 and was adopted by the ASTM later on. As shown in the formula, the N stands for the number of flows in the liquid limit device. Always remember that the value of the tangent beta differs from soil to soil. For fine-grained soil, the value of the tangent beta is 0.121. And that's it. Those are the thorough explanation of the 3 ways to determine the liquid limit of the soil. For now, let us have some sample problems. Sample problem number 1. Using the Casagrande cup method, the following data are obtained from the liquid and plastic limit test for soil. Determine the liquid limit. The following data are the following. Number of flows are 16, 20, 28, and 30, with corresponding moisture content of 36.5%, 33.1%, 27%, and 24.7%. Since the given data needed are already present, we will proceed to the plotting of data. This graph shows the relationship between the number of flows and the water content. I stand corrected regarding my mistake as shown in the graph. The label of the y-axis should be water content instead of moisture content. As observed, the plotted data are approximately in a linear manner. Therefore, in order to identify the value of the liquid limit, we must identify the intersection point of the 25 number of flows and the water content. For this case, the liquid limit is at 29% at 25 number of flows. In a liquid limit test using a cone penetrometer, the following readings were recorded. Identify the liquid limit of the soil. The data are as follows. Moisture contents are 28.8%, 40.3%, 49.8%, 61.3%, 67.2%. And for the corresponding coin penetration, 22.3 mm, 15.7 mm, 17.9 mm, 20.5 mm, and 21.8 mm. Since the given data needed are also present, we will proceed to the plotting of data. This table shows the corresponding relationship between the cone penetration and the moisture content. As observed, the plotted data are approximately in a linear manner. Therefore, in order to identify the value of the liquid limit, we must identify the intersection point at which the 20 mm penetration meets with the moisture content. For this case, the liquid limit is at 59% at 20 mm cone penetration. And that would end my presentation regarding determining the liquid limit of soil. Once again, there are three methods. Those are full cone method, Casagrande cup method, and the 1-point method. Thank you for sparing some time and listening.